Hello everyone, welcome to Chemisans, and today we are going to start a series wherein we will be addressing few important topics of IGCSE chemistry examination. As you know that the examination will be starting this month. Okay, so the first topic which we have here is handling titration numericals. Right, so there are certain things which you should know. The first thing is that we are actually talking about acid-base titration here, right? So that thing must be clear that in this type of question you will have one acid, right? So there is going to be an acid and there is going to be a base, and the formula which you will be using will be MAVA equals to MB and VB. Here A stands for acid and B stands for base, right? And the word V is for the volume and M is for the molarity. So before we proceed ahead, it is very important for us to understand what is molarity. So let us try to understand molarity first. Only then we will be able to appreciate titration, right? So molarity is a way of measuring concentration, right? So there are many ways of measuring concentration. So one of the ways for measuring concentration is molarity. And the formula of molarity is number of moles upon volume of solution. And the volume of solution has to be in liters here, right? So this is the formula of molarity. Obviously, if I take N on one side, so I basically get MV. Okay, so that is how this MV has come here. So in this type of questions, basically they take an acid and they take a base. Okay, and see, there are four variables here, that is the molarity of acid, the volume of acid, and the molarity of base and the volume of base, right? So out of these four variables, three will be given to you and one you will have to figure it out on your own by using this formula, that is MAVA equals to MBVB. Now, let us have some clarity with respect to this formula. Okay, the unit of molarity is mole per decimeter cube. Okay, so this is going to be the molarity of the unit of molarity, right? There are certain things which you need to keep clear in your mind, that is 1 ml. Okay, 1 ml can also be written as 1 centimeter cube. That means in 1 liter we have 1000 ml. That indicates that we are going to have 1000 centimeter cube in a liter, and also 1 liter is equal to 1 decimeter cube. So please don't get confused with centimeter cube or decimeter cube. You just have to remember that 1 ml is 1 centimeter cube, and accordingly 1 liter will have 1000 centimeter cube. Right, so these are some basic information which you must keep in your mind to solve the titration numericals, and that way when we solve these examples which are just to follow, your titration numericals will come very handy and you will feel very comfortable while you are being assessed based on this, right? And there's a high probability of this question being asked mostly in the theory part. Okay, however, it can come indirectly in the form of MCQs also, so your prior knowledge for this is required here, right? So now we can start with very easy examples and gradually we increase the difficulty, and at the end we will be practicing some Cambridge questions as well. Okay, so I hope you have understood till this point. Now let's get started with the solved examples. So this is the first equation which we have over here, right? Now let us try to identify our acids and bases here, right? So here you can see HCl here, right? So this is your acid, right? This is your acid. And if you see sodium hydroxide, which is also known as caustic soda, is your base here. Now this is the question, right? So they are telling us, so here they have not taken centimeter cube, they have taken ml. Okay, so they have taken 50 ml of HCl solution, right? So 50 ml of HCl means this is the value of Va, Okay, this becomes the value of Va. Okay, the 50 ml of HCl solution is taken with unknown concentration, means the molarity of base is not unknown concentration, titrated with 0.25 m of NaOH. Okay, so the molarity of HCl is not known here. Okay, we know Va, but Ma value we don't know. So as I already said, our formula is going to be MaVa equals to MbVb, right? So here the question itself has made it very clear that we have to find the value of Ma. Okay, now let us see what is given in the question. This is the volume of A. Now they have also given you the volume of base. Okay, they have given the volume of base as 35.23 ml, right? And accordingly, if you read the question properly, they have also given you the molarity of base, which is nothing but 0.25 m. Okay, so you have to mark this value as well. So here your 0.25 m is nothing but the molarity of base. So if you see all the parameters here, we know the value of Va, we know Mb, we know Vb, and we have to calculate Ma. But before you proceed ahead, it is very important for you to balance the equation. Okay, you have to balance the equation before you actually proceed for the calculation, right? So here you see this equation, you are lucky that it is already a balanced equation over here, so you will not have any issue as such, right? So this is how the question is going to look like. This is the simple equation. Now the equation for this is going to be, right, Ma Va equals to MbVb. Now we will have to put all the values and calculate the concentration, okay, the unknown concentration of acid. So we have to calculate this part, right? So let us start with the solution of the same, right? So here, if you look at it, okay, I have already put the values here. So you can see our formula is going to be MAVA equals to MBVB. Okay. So here MA I have not disturbed. This 50 ml was given as the volume of acid, and MB value is nothing but the molarity of base. It's already given 0.25, and here this is the volume of base. Okay, some of you might ask question that, sir, the volume has to be taken into liter, but here you have taken into ml. Yes, you can take it into liters, but you know, if you take 50 ml into liter, it's going to be 50 by 1000 on the left hand side, and 50 again, it's going to be 35.23 by 1000 on the right hand side. So ultimately by 1000 are getting cancelled both the sides. So that's why whether you take it or not, it's not going to change your answer as such, right? So when you put all the values, obviously the value of Ma you will be able to get. Okay, so that is nothing but 0.176 m. Okay, so this is going to be the molarity of acid. Now you need to remember one more thing, that in IGCSE examinations they are often asking the strength also. So this is the molarity of acid, and you know that our acid is HCl. So this is the molarity of acid. They also ask the strength of acid. Okay, so this molarity is in mole per decimeter cube. Okay, this is the unit of molarity, but they want the value in gram per centimeter cube. Okay, so when they ask for the value in gram per centimeter cube, basically they are asking for the strength of the acid. Okay, when you particularly find the weight of that acid, so you are basically trying to find out the strength of that acid. Now let us try to find the strength of this acid in the next slide, right? So I hope you all will be able to solve this, and then accordingly in the next question you have to apply the same tricks which I have told, and you will be getting the answer, right? So to calculate the strength of HCl, we will have to find the molecular mass of HCl first, right? So we already can see from the periodic table that the mass of hydrogen is 1 unit, okay, and the mass of chlorine is 35.5. So the mass of molecular mass of HCl will be 1 plus 35.5. When you calculate it together, you get the value of 36.5, right? That is, let's take it 36.5 grams. Okay, so this is the molar mass. Now to find the strength, okay, To find the strength, you will have to multiply the molarity into the molecular mass for HCl. Okay, so the molarity you can already see here, right? So the molarity is 0.0176. So we write 0.176 here, right? And we just multiply this into the molecular mass, that is 36.5, right? And when you do all this calculation, you get your final answer. So that is nothing but 6.424 grams. Again, you will write grams per decimeter cube. And this particular thing becomes the strength of the acid. Okay, so I hope you have understood our first solved example, how we calculated the unknown concentration of our acid, which is hydrochloric acid. This acid is also found in your stomach. Now the time has come to go for the second example. So if you have really understood the first question, you will not have any difficulty in the coming question. Okay, so let us start solving the second question. Now this is again a similar question. We have got the same equation. It is just that I have made the numerical values difficult so that you can practice that aspect also. So we already know this neutralization reaction. Here our acid is HCl, right? And it is going to react with the base, that is NaOH. And when both acid and base react, we get NaCl plus water, and it's already a balanced equation, so we just need to identify the parameters here, right? So here you see this is the volume, this volume of HCl. So this becomes Va, is completely neutralized by a base. Okay, so this is volume of base, and this is the 0.25 is the molarity of base, right? So we have got the volume of base 35.8 ml, and we have got the solutions molarity, basic solutions molarity also. So ultimately we have to find the concentration of HCl solution which we have used in this solution. Now we can very well start with this question now, right? So let us start by writing the equation. Okay, so our equation is MAVA equals to MB into VB. Okay, so there will be no coefficient fixed because this is already a balanced equation. Okay, so now let us see what will be the value of MA then. So we already know MA will be nothing but MB upon VB, okay, divided by VA. So let us find out the value of molarity of the acid here. So what is the value of MB? As we can see from the question, it is 0.25. Then this has to be multiplied into the volume of base, and the volume of base is 35.8 ml, right? This has to be divided, okay? This has to be divided by the volume of acid, and volume of acid, as you can see, it is 24.7 ml. So let us write 24.7 ml as well. Okay. Now when you solve all these questions, okay, when you put them, then you get the correct answer, right? So here 0.25 into 35.8 is nothing but 8.95, right? So let us write 8.95 in the numerator. Okay, 8.95 in the numerator, and in the denominator we have 24.7. Okay, so when we solve all this, okay, you just have to divide 8.95 divided by 24.7. So your answer is 0.36. Okay, so we have got the answer of 0.36 here, right? And already we should not forget the unit. The unit is going to be 0.36 mole per decimeter cube. Okay, this is the answer for this. Okay, 0.36 mole, this is the concentration of acid here. So you see in this particular reaction we have found the concentration, okay, the unknown concentration of HCl solution here. As we are discussing acid base titration, so there will be an acid, there will be a base, okay, and the formula, this is the formula which you have to apply, and you get the molarity of unknown acid. Now let us try to find the strength of the acid also. Okay, now strength of the acid, as I already told you, we know the molecular mass of acid we calculated. Okay, for HCl we calculated, it is 36.5 grams. Okay, that is the molarity of acid. Now you will have to multiply this with the molarity of HCl, that is 0.36, right? So when you do this, you get the answer as 13.2 grams. Okay, 13.2 grams. Again, it is per decimeter cube. So this is going to be the strength of HCl. Okay, let me write it here. This is going to be the strength of the acid, that is HCl. So everyone, this was the second question which we have solved, which was having the same equation. Now in the next question, we are going to make the equation a bit complex, okay, where there will be requirement of balancing. Okay, so let us go to the third question now. So in the third question, again, I have already told you, given you hint that this time we are going to have a different kind of equation. Okay, so now here let us try to solve this question now, right? So this question can be very easily we identified. Okay, you see, this is the base. You know, metallic hydroxides or oxides are basic in nature. So this is going to be our base. Okay, so base is barium hydroxide and our acid is nitric acid. Okay, so we have identified the acid and base. Now let us do their neutralization reaction. Okay, so here for doing neutralization, let us write the acid first. So here acid is nitric acid, so I am writing HNO3, and this is reacting with my base, that is barium hydroxide. And we all know that acid reacts with base to give salt and water. So here the salt will be barium nitrate. Okay, so how barium, we already know that barium is +2 charge and nitrate is -1 charge, and there will be crisscross. So the formula of barium nitrate will be BaNO3 whole twice. Okay, so in case you don't know that, this method will be helpful for you, right? So now let us directly write barium nitrate now. Okay, yeah, so we are writing barium nitrate, BaNO3 whole twice, and obviously salt plus water. So this is H2O. Now we will have to balance this equation, right? So the balancing can be done very easily here. Okay, so if you look at the equation, if you just put this hydrogen, if you see, it is 1 here, and hydrogen it is 2 here, so if it is 3 here. Okay, obviously this is 3 here, and it is not matching with this 2 here. Okay, and the metals, obviously barium, they are matching here, right? So we just have to balance this. We can put 2 here, and we can put 2 here. Okay, it's a trial and error type of thing. Okay, so now let us see if this equation is balanced or not. Okay, so you see, hydrogen is balanced, nitrogen is balanced, barium, 1 on both the sides. Okay, both the sides. So this is important. In earlier in the neutralization reaction, there was no requirement of balancing because it was already a balanced equation. But here you are supposed to balance the equation. Only then you can form an equation. Now let us write the formula we write for titration. Okay, so we know for titration we write MaVa equals to MbVb. Okay, so this is what we write, but now this time you will have to write it differently because this is not this requires 2 and 2 to be there. Okay, so let us write it like this, like MaVa upon MbVb equals to. So you see, for acid we have got 2 moles, and we is reacting with 1 mole of base, so you will make it 2 upon 1. Okay, because 2 moles of nitric acid is reacting with 1 mole of barium hydroxide, so we take it 2 upon 1. Okay, so now the equation becomes okay, let us see what is not known in the equation. So this volume of molarity of base is given, so this becomes Mb. Okay, completely neutralized 45 ml. So volume of acid is given, and the molarity of acid is given. So we know that the volume of base is missing. Okay, Vb is missing. So let us write Vb will be equal to. Okay, so Vb. Okay, Vb, we'll have to find out what will the value of Vb. So obviously, if you have this equation, you can very well separate Vb here, right? So this is how the volume of base, okay, in this case it is barium hydroxide, which can be calculated. Okay, so let us see the detailed solution in the next slide. Okay, so this is the slide wherein you can find out the answer, right? So I have already explained how we have to balance this entire equation. So see, we had balanced this entire equation in this. Okay, so we got 2 here and we got 2 here. So ultimately what we saw that 2 moles of acid, they are reacting with 1 mole of base. So you make it like this. Okay, MAVA upon MBVB, and when you get it like this, okay, you just have to find the volume of base, and the answer is 43.5 ml, right? And accordingly, when you multiply it with the molecular mass, okay, this is going to be the volume of base. Okay, now let us go to the fourth question now. Okay, so I hope you have understood how balancing equation is important for this particular question, right? So here we have got the next question. Now this question I have directly taken from IGCSE. Okay, and it's the latest question. I think it's from the year 2022. So let us try to analyze the question from our end, and then we will go for solving this question. You are lucky in one way, because they have already given you the equation, that to balance. So we just have to analyze this. So in a titration, a student added 25 centimeter cube of zero point 0.2 m of aqueous sodium hydroxide. So your base, okay, this is your base. Your base is sodium hydroxide. This, they have given volume, so this becomes Vb. Okay, and this is the molarity, see, mole per decimeter cube. So this becomes Mb. So Vb, Mb given in the solution. They have taken methyl orange, that means red color in acid, orange color in neutral medium, and yellow in base. Okay, so that is the indicator which they have taken, and generally they take methyl orange only. And ultimately what happened, they are adding one acid, that is sulfuric acid. Okay, our base is sodium hydroxide and our acid is sulfuric acid. So they added to the burette. Okay, and the volume of sulfuric acid which was required to neutralize the sodium hydroxide was 20 centimeter cube. Means when they added 20 centimeter cube of acid to sodium hydroxide, the neutralization happened. So now the entire equation is here in front of you. Okay, and you already know that 20 centimeter cube volume could neutralize the base. Okay, this acid could be neutralized by this much. Okay, this much acid was taken to neutralize the base. Okay, so this become volume of acid, right? This is your volume of acid. So or we, it is very clear, we have to find the molarity of acid here, right? So how do we do that now? Okay, again, very easy. First you have to write the equation, that MAVA upon MBVB equals to. So you see, you have 2 moles of base reacting with 1 mole of acid. So 1 mole of acid is reacting with 2 mole of base. So ultimately what the equation becomes, the equation will become MAVA. Okay, okay, MAVA equals to 1 upon 2 of MBVB. Okay, and ultimately we need to find the value of MA. So here MA will become MB into VB divided by 2 into VA. Okay, so this is going to be the overall equation, how you can find the molarity of acid here, which is sulfuric acid. Now in your actual examination, you will be given marks for writing each and every step, right? So it is a stepwise thing, and here also you'll have to calculate the strength. So let us see how questions like this have to be done. The next slide. Okay, so see, this is what was supposed to be done. You saw 1 mole of acid was reacting with 2 mole of base. Okay, so ultimately you will be able to find the molarity of acid, okay, which comes around 12.25. Okay, so here you can see the value of acid. It is 12, sorry, 0.125 mole per decimeter cube. So this is the value of mole of acid. Okay, the concentration, the unknown concentration of acid. Okay, now they also ask at the end, they will ask the strength. Okay, they'll ask the strength of acid. Now we already know the acid which we have taken here is nothing but H2SO4, which is sulfuric acid, and you have to calculate the mass. So you know the mass of hydrogen is 1, sulfur is 32, okay, oxygen is 16. If you don't remember the values of the mass of this, you can always take the help of periodic table. So it is 2 plus 32 plus 4 into 16. So ultimately you get 98 gram as the molecular mass of the sulfuric acid. The strength is molecular mass of the acid, which is 98, into the molarity of acid, which is 0.125. Okay, so when you do this step, you get 12.25 gram per decimeter cube as the strength. Okay, so this is the concluding, this happens to be the concluding step of titration. Now we will do one more question of titration, which is based on our IGCSE examination. Okay, so let us see that now. Right, so here is again a very simple question, you all can see. Okay, and I told you that they will be giving you the neutralization reaction, and that to balance, you don't have to balance also that. Okay, but it is always better to have a balancing practice, but here in this type of question they will give you the balanced equation. So obviously it is very clear in the question, our base is calcium hydroxide, acid is HCl. Okay, so now if you look at the equation, how the equation can be done in this case, we know again MAVA upon MBVB. Okay, now let us see, 1 mole of acid, a base, is reacting with 2 mole of acid here. So basically this equation becomes, we have 2 moles of acid reacting with 1 mole of base. So ultimately this equation becomes MAVA equals to 2 into MBVB. Okay, so this is going to be the equation which will give us the answer. Now let us see what is being asked by the question. So 20 centimeter cube of 0.05 ml of HCl. So this is your volume of acid, this is your concentration, that is molarity of acid, and they have given volume of base, and they are asking, obviously they can ask only one thing, that is molarity of a base here. Okay, they will be asking molarity of base. So obviously if you have to find the molarity of base according to this equation, you will have to write Mb equals to Ma upon Va, right, divided by 2 into VB. Okay, so using this formula you will be able to get the molarity of base, and obviously the unit of base will be molarity will be mole per decimeter cube. Okay, it's going to be mole per decimeter cube. Right, so let us see a detailed solution of this and try to see how this question has to be attempted while you're giving your examination. Okay, so here is the detailed solution. As you can see, I have written the equation also here, right, and we have already concluded how the equation is going to be. So see here, they are calculating the moles of base, right, so you get the molarity of base as 0.02 mole per decimeter cube. Now you have to calculate the strength. Okay, whenever they ask you to get the value of base in gram per centimeter cube, that means they are asking you the strength of base. So obviously you will have to find out the molecular mass of calcium hydroxide, and we already know that the mass of calcium is 40, oxygen is 16, hydrogen is 1. When you put all these value, you get 74 gram as the mass of calcium hydroxide. And remember, calcium hydroxide is a metallic hydroxide, it's basic in nature, and it is also known as slate lime. Okay, so when you put this value, you just multiply 74 into the molarity of base, that is calcium hydroxide, and you get the answer 1.48 gram per decimeter cube as the strength. Right, so this is how we need to solve the titration question. I don't think there will be any questions left after this. If you have any queries related to acid based titration, or you have got any question on your own, so you can share the link of that in the comment section, or if you have got any queries, you can let me know. So I hope these examples must have definitely helped you a lot to tackle these titration questions, and there won't be any issues as such now. Okay, so I wish you all the very best for your examination which you have this month. Okay, we are starting with the theory examination, and I hope you come out with flying colors and do well. My best wishes are there with you. Till then, everyone, stay tuned, keep learning. Thank you. Jai Hind.